Welcome back, my dear students. In today's session, let us learn about the functional groups. I found many students finding it very difficult to understand this concept. So let's get started. What are functional groups? Now in previous sessions, I already explained you, hydrocarbons are the parent organic compounds. Now all other compounds are considered to have been derived from them by replacing one or more of their hydrogen atoms by some other more reactive atoms or groups. So let us consider this hydrocarbon R H. Now what is this R? If I consider methane, then CH3 group is called as R. This hydrogen is as it is. Only this CH3 group is called as R. It is an alkyl group. Now, if I replace one or more hydrogens from the given hydrocarbon, I remove one hydrogen, introduce a group or an atom, then I get a new molecule called as Rg. So every molecule consists of two parts. One is R and the other one is G. What is R? R is the carbon-hydrogen framework of the molecule. Okay. So in the previous example you saw. What is R? R is the carbon-hydrogen framework of the molecule. And what is G? G is functional group. What are functional groups? A functional group may be defined as an atom or group of atoms present in a molecule which largely determines its chemical properties. I told you that there are two parts. R is a part of molecule which largely affects physical properties. It affects physical properties such as melting point, boiling point, density, refractive index. Now, suppose R is attached to an OH group. So this is a functional group in place of G. Then I call it as alcohol. I call it as alcohol. In all the chemical reactions of alcohols, it is the OH group that undergoes change, while rest of the molecule, that is R, remains unchanged. Similarly, if R is linked to COOH, then the entire property of the molecule depends on COOH group. This is carboxylic acid group. So what you need to understand here is that the chemical properties of any organic compound are the properties of its functional groups. Organic compounds containing same functional group show similar chemical reaction. So to understand this, let us consider an example. Now, 2ROH When I treat it with sodium metal, I get 2RONA plus H2. What is this R? R can be CH3 or CH3CH2, or it can be CH3CH2 twice CH2. So what is a common thing here? Any alcohol, when it reacts with sodium metal, a molecule of hydrogen is liberated. Now, let us look at some of the functional groups and classes of the organic compounds. Now, are linked to G. So, what is this G? G is the functional group. Okay. Now, the different class of compounds are alkanes, which has carbon-carbon single bond, alkenes, which have carbon-carbon double bond, alkynes, carbon-carbon triple bond, arenes, an aromatic compound, halides, where halogens can be fluorine, chlorine, bromine, iodine. In case of alcohols, OH is the functional group. Aldehydes, CHO is the functional group. In case of ketones, C double bond O is the functional group. Nitriles, C triple bond N is the functional group. In ethers, ROR, that's the functional group. Carboxylic acid, COOH is the functional group. Carboxylate ions, COO minus. In case of esters, COOR is the functional group. Acyl halides, COX. Once again, X is fluorine, chlorine, bromine or iodine. In case of amines, NH2 is the functional group. Amides, CONH2 is the functional group. Nitro compounds, NO2 is the functional group. Sulfonic acids, SO3H is the functional group. So with this, we have completed the functional groups topic. Thank you for joining. See you in the next stream.